Hi, guys. All we have left to do with taking limits analytically is to talk about step function and absolute value, because we're gonna do them the same way as the others, but they can be scary when you first go. So most of what you have to practice today is just practice on things we've already done. These are the two new things that I want to make sure we talk about. So step function. I think step function is easiest to do if you have a picture in front of you. So I'm gonna sketch a quick little sketch of step function. And I don't know if you remember this, and I can't see your faces, so I'll never know. But I'm going to draw it for you. Close circle on 0, and then to open. And once you have one of them, you have all of them. So it's just got to line up really nicely. So here's 1, 2, 3, and I'll do a couple this direction just so you have it for other questions you might be working. So there's that. All right, that's all I need, because now I'm just going to do this graphically. So I know it's under the analytical stuff, but I tackle these graphically. So here is 1, and here is the right of 1. And if I sit here and start backtracking towards my value, and this thing is approaching a y value of 1. Same thing, other side, there's 1. Here's the left of 1. If I sit and try to go back, the y value this approach is approaching exactly 0. So now that I have both of those, this is really quick to do a does not exist because the left and the right don't match. I will tell you that if this question gets asked to you, it's going to be this asked of you, probably, on the AP test. And you're going to have to know to approach from both sides and to test the left and to test the right, and then they don't match and you get to pick does not exist. All right, that's step function. So step function is kind of a trick. You're just going to do it with a quick sketch of the step function and then plug in and see what happens. Absolute value is the other one. We're going to do absolute value limits using the definition of absolute value. So I could ask people, I could call her, I could ask, but I just know that you were taught the definition of absolute value as a piecewise function. So I just know, without actually knowing, that you were taught this, that this function is equal to its positive and it's equal to its negative. And the split happens at its vertex. So this would be for x is greater than 0. This one would be for x is less than 0. Which one gets the or equals to does not matter when we're doing limits, because remember, limits are for approaching, not for all the way equal to. So it doesn't matter. You can throw in there just to be super precise, and that's great. All right, so that's the piecewise definition of an absolute value. And that's what I'm going to use over here in this question. But I can't use it for just absolute value of x because my question has more than that. So I need to make a piecewise definition for the absolute value of x minus 1. Please note, I'm not doing any calculus yet. I've not even addressed the fact that there's a limit. I don't care yet. I need to try to piece. So this is going to be equal to two things. It's either going to be positive self or its negative self. Yes, I know I could distribute that negative in, but that defeats the purpose. I'm not going to do it. The split, where it changes from its positive function to its negative function or vice versa, happens at its vertex. All right, so what do you remember for graphing absolute values? This thing is a V shape, and it got shifted to the right one because it's got a -1 in here. If I just blew your mind, then that's okay. All you're really doing is finding its zeros. So you're just taking the inside there, setting it equal to 0. That split happens at 1. So this would be for x is greater than 1. This would be for x is less than 1. Again, it does not matter which one gets 4 equal to. I'm going to throw it right there. Okay, time for calculus. Because now I'm actually looking at the limit. This limit is for x approaches 1 on the left. The left of 1. 1 on the left, a little bit smaller than 1. So when I'm looking at this absolute value function, I'm only looking at this one because this is for x is less than 1, left of 1. So this limit doesn't involve this half of the function at all. I don't need it. I'm not going to write it. It's a waste of my time. I'm going to rewrite this limit now using my definition. So 1 on the left, I'm not going to write absolute value. I'm going to write what it actually is. It actually is negative x minus 1, still over x minus 1. And now I can do really fun fast algebra where these cancel, reduce to 1. And okay, that's using a piecewise. I just want to show you that I could have asked the same question using a limit of x going anywhere I wanted to. I could have asked for 1 on the right, and then you would have to use this guy that I crossed out. I could have asked for a limit as x approaches 77 because I felt like it, and you would have used this one because this is for x is greater than 1. I could have asked for a limit as x approaches negative 8,225, and you would have used this one because that's the one for x is less than 1. You just have to use the piece of your limit to decide which piece of your piecewise function you're actually looking at. So the only way you have to do double duty is if I give you the same thing and I ask you just to go to 1. This is the only situation where you have to split it up into 2 limits, one from the left and one from the right, because that split from left to right, you're on 2 different functions for your absolute value. Okay, I hope that made sense. If it didn't, we can talk when I see you next. Enjoy.